In this illustration, we'll analyze the lifting of a conical vessel. We are given that a conical vessel without a bottom stands on a smooth table, and a liquid is poured in the vessel, and as soon as the liquid level rises to H, the vessel is lifted up at the bottom by liquid pressure. And here we are given that the base radius of vessel is R and its weight is W. We are required to find the density of liquid. Now in this situation here, if we analyze the situation and we calculate the normal reaction at bottom due to liquid pressure is, if we calculate this normal reaction, this will be H rho G multiplied by pi r square. Here for analysis we can redraw the figure. If this is the ground and this is the vessel and the liquid is filled up to a height H, then in this situation at bottom, here we can see the force applied will be H rho G pi r square, and the same normal reaction will be acted upon the liquid due to the ground. And this normal reaction will be balancing the weight of liquid as well as the force applied by walls on the liquid in this direction like this, which I am drawing here. So the force which the liquid is exerting on the container, the upward component of this force will be the same as the downward component applied by the vessel walls on the liquid. So if we write it as F up, then here we can write for equilibrium of liquid, here we can write the upward force is N and downward is its weight, mg plus force in upward direction which on liquid is acting in downward direction. So here we get the upward force on vessel walls is this F upward we can write as this N minus mg, so it is H rho G pi r square minus mg. So in the situation if it is H rho G pi r square minus mg, then in this situation we can say the vessel will be lifted up when this is equal to the weight of vessel. Then in this situation the mass of liquid can be given as the volume of liquid multiplied by density. So here we can write it H rho G pi r square minus m can be written as V rho G is equals to W. So in this situation here, first we can calculate the value of this volume of liquid, and then we can substitute it here to get the value of rho, because we are required to find the density of liquid. So from this relation we can see the density of liquid rho we are getting is W divided by Hg pi r square minus Vg. So we just need to substitute the value of the volume of liquid in this situation, and here we can calculate the volume by extending the vessel walls and completing this cone. And in this situation, if we consider R is the radius of this surface of liquid, then we can easily relate this R, capital R, which is the radius of base, and as here it is filled up to a height H, and the half angle of this cone is given as alpha. So here we can write this small r is equals to capital R minus H tan alpha. And in this situation, the volume of liquid can be given here. We can write volume of liquid is V, and this we can write in the whole volume of this cone, we subtract the volume of upper cone, which is 1 by 3 pi, and this will be r cube cot alpha, which is the volume of this whole cube, minus it is 1 by 3 pi small r cube cot alpha. And in this situation, if we substitute the value of a small r over here and we substitute the value of v over here, this will give us the final result as w divided by pi h square g tan alpha multiplied by r minus h by 3 tan alpha, which is the result of this problem. And from here to here, you need to substitute the value of this volume here and substitute the value of this r over here. This I am leaving as an exercise for you to calculate and verify this result, which is the density of liquid we are required to calculate.